Assalamualaikum and selamat sejahtera. In this video, I will explain the basic procedures to design a DC-DC converter. Before designing any converter, you must set the input voltage value. It depends whether you are using a battery, DC generator, photovoltaic, or programmable DC power supply. Second, set the output voltage value. Third, set the output power of the converter and use it to calculate the resistive load value using this following equation. Next, calculate the duty cycle using the output voltage equation of the converter. Later, set the switching frequency of the controllable power switch. And lastly, set the percentage of the output voltage ripple of the converter. Based on these settings, we can determine the size of the inductor and capacitor of the converter. For your information, in the converter operation, the inductor and capacitor can affect the quality of the current and voltage waveforms in terms of the ripple percentage. Practically, a high-quality DC waveform should have a small ripple percentage. Before I show you how to design the inductor and capacitor, I want to explain about the ripple value of voltage and current waveforms in a DC-DC converter. Once again, I will simulate a buck converter circuit. Ideally, all steady-state voltage and current waveforms in the DC system are constant and ripple-free. Hence, the amplitude of the waveforms represents the average value of voltage and current. Nevertheless, as shown in the previous video, when we zoom in the inductor current waveform, we can see the wave shape of the current is not actually constant and it consists of high ripple components. Similarly, when we zoom in the output voltage waveform, we can see the wave shape of the voltage also consists of ripple components. Next, I will show you how to calculate the ripple value using the peak-to-peak amplitude of the waveforms. According to the simulation, the peak-to-peak amplitudes of these waveforms is as follows. Based on the figure, the ripple value of these waveforms is referring to the difference between the maximum and minimum amplitudes. First, let's start with the ripple output voltage. According to the output voltage waveform, we can calculate the ripple value as follows. Next, let's look at the ripple output voltage as a fraction of the average output voltage. Before we can calculate the value, we need to calculate the average output voltage using these equations. And eventually, the percentage of the ripple output voltage is equal to 0.5%. Next, let's calculate the ripple inductor current using this following equation. As usual, to determine the percentage of the ripple inductor current, we need to calculate the average inductor current. As a result, the percentage of the ripple inductor current is 83.6%. To ensure the DC-DC converters work in a continuous conduction mode, the selection of the suitable inductor size is very crucial. To design the inductor, there are two approaches you can choose. First, you already set the percentage of the ripple inductor current. Therefore, you can determine the inductor size using the equation of the change of inductor current. For a buck converter, you can use these following equations. You can use either equation 1 or 2 for your calculation. Nevertheless, if the percentage of the ripple inductor current is undecided, we need to identify the size of the inductor using the critical inductor value. For this technique, we cannot control the percentage of the ripple inductor current. As usual, I will show you how to design the inductor of a buck converter using the critical inductor value. After watching this video, I hope you can try to design the inductor of boost and buck boost converters using the same procedures. In total, there are 10 steps to design the inductor. First, we need to choose one delta ILT equation. Since the second equation has only one voltage parameter, thus, I will choose this equation for this procedure. After choosing the equation, we need to rearrange the equation to obtain the inductor equation. Next, we need to shift our focus to the waveform and equation of the inductor current. To determine the critical inductor value, we need to consider the critical condition of the inductor current waveform. It happens when the minimum amplitude of the waveform equals to 0. This condition is considered critical because the converter will work in the discontinuous conduction mode if the minimum current is less than 0. Therefore, we need to move the inductor current waveform downward until the minimum current equals to 0. According to the new position of the waveform, the new value of the minimum amplitude is equal to 0. Thus, the ripple inductor current is now equals to 2IL. And therefore, we can rewrite the inductor equation as follows. Eventually, this equation represents the critical inductor equation. Since the equation consists of the average inductor current, thus, we will focus on the average current of the converter. To show all average current in the circuit, you must remember that in the DC system, the average current of a capacitor is always zero. Thus, we can label the average currents as follows. To analyze the average currents easier, we must consider all power switches in the converter are turned off. Next, we can apply KCL at this node to obtain the inductor current equation. Eventually, we can see the average inductor current is equal to the output current. For the next step, we will substitute the output current or supply current, if existed, using Ohm's law or power equation. Since the equation consists of the output current only, therefore, we just need to apply the Ohm's law. Later, we need to eliminate the voltage parameter in both equations. First, we need to combine the equation of the critical inductor and average inductor current together. Second, if the equation consists of two different voltage parameters, we need to apply the output voltage equation to obtain one type of voltage parameter only. Therefore, the equation will change as follows. Finally, the actual inductor value can be calculated by increasing the critical inductor value by 10% up to 20%. It is to ensure that the converter will work in the continuous conduction mode. That's all from me, and I will see you again in the next video.